The overall goal of the synthetic method of combining a vapor transport deposition technique and nitrogen etching method in an atmospheric pressure system is to demonstrate fabrication of high-quality, large-sized, single-layer materials on dielectric substrates.
This method provides a general strategy for the growth of two-dimensional large-sized single-layer materials, such as tin sulfide, germanium satellite, and indium telluride. The main advantage of this technique is that large-sized single-layer flakes can be grown on low-cost silicon dioxide, silicon dielectrics with a vapor transport deposition technique and a nitrogen etching method in an atmospheric pressure system.
The implications of this technique extend towards the fabrication of other two-dimensional materials because the self-limiting nitrogen etching method can be beneficial to the formation of single-layer samples.
I first had the idea for this method when I carried out the growth of tungsten disatellite, tin satellite, heterojection under nitrogen atmosphere, and found that nitrogen etches the material.
First, set the target temperature of a horizontal tube furnace to 560 degrees Celsius for 1 hour and run the furnace. When the temperature approaches 560 degrees Celsius, press the set key for 2 seconds. Once the parameter HAL pops up, press the set key for 1